Is my final project, and it takes a while for the turtle to make it, so I am going to actually run it in the background. Oops. And that. And that. So, I have 6 boxes. Each time I'm setting up a box and then I'm moving in order to create the next box. Each one will be slightly different, so I can't automate that. The first one is a very simple box with lots of fun colors, as you can see. Okay, so first I decide to divide the length of each box by the number of boxes I want to make. So that way each side will be that length. So in other words, if I want 100 or 10 boxes, I would divide it by 20. If I want 10 boxes, I would divide it by 10, so I'd get 20 because the box length is 200. So then this is all of the rows of boxes. And so it's going to run row of box. So this will be each row of boxes. And for each row, we're going to make a box. And then we're going to move forward to make the next box. So the box, in each box, we're going to create each one. So, range 4, so as it makes each box. And then on top of that, we're just going to make more triangles. And then here's where we're making the triangles. And I use random integer in order to just create a random color every single time, because I think it looks prettier that way. The next one, as you can see, is a bunch of hexagons. And so again, we're creating all the rows, and then here's each row, and then we just go back and create each new row. So for each row, if the iteration that was passed through is divisible, if divisible by 2 equals 0, then I'm going to run these. So in other words, these lighter colors. Otherwise, if anything else, it runs these guys. So they're the same thing, except changing in color and position, because, yeah, just changing in color. So each time it creates each hexagon, because one is slightly higher than the other. And so it creates one hexagon, and then it moves to create the next one, and then at the very end we create the very last one, because it's not an even number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then the 13th. So that's why we run this only 6 times for each 2. So each time it calls full hex. Full hex is really simple, it's just a hexagon, and then it creates it all. And the next one is this crazy looking guy. This guy was a bit harder to make because I didn't know how to exactly make the triangles, but I figured it out. Same with everything else, I'm creating all the rows, and then we go back to make each row. And then I have a special definition just for the very last row, since it's truncated. And as you can see, it barely fits by 1 pixel. So each time it goes through, it calls hext, and it passes through 10, which is the size. There we go. And then for each one, first we call mini triangles, which is all of these triangles here. But mini triangles incorporates the drawing of the triangles plus setting itself up for the next one. So in mini triangles, I have it making a triangle left and then right, and it does that twice, and then it creates a little oddballs right here because it's not perfect. But then you just repeat that 3 times, and then you have the entirety of the hexagon. And then, after we've created all of the triangles around the hexagon, I just make the hexagon. And then we set up for the next one. So, that's, for the most part, all of these rows. And then we're going to make the last row. Last row with same size 10. For the last row, we make 5 of these. And in each we only make 2 of those mini triangles instead of 3. And then I finish the weird bottom part with this function or definition called final bits. And final bits is just a bunch of hodgepodge just to make it look nice. Alright, this pretty rainbow one is the 4th box. Alright, so same idea as the rest. I'm creating all the rows, and then I'm creating each row, and then heading back to make the next one. And then here's the next row, and then I head back to do it all over again. So for this one, it creates each other row. So 1, 2, 3, 4. 1, 2, 3, 4. So each time we're going to call row poly 12. And I have a special color list because I wanted it to be a rainbow. And it had to be very specific because each row is going to have only half of the rainbow. And first you set up each one, and then depending on the number I pass through, whether it be there it is, 0 or 4, depending on the list location. It'll be the number plus I every time it goes through, so I just iterate through the list, either starting at 0 or starting at 4. So each time we're going to do polygon poly 12. The dodecahedron is a 12-sided shape, so I have this running half that, since I accomplish 2 sides with every iteration. So obviously first I just move forward, and then I make a square. And then at the very end of that, it fills it with this color. But very specifically the square, I chose not to color the very last line, so that way it looks like a full shape. So it has the effect that it was never actually fully filled. Second to last is my first fractal I tried, and it's actually really pretty. And same as the rest, sets up all the rows. This is each row, so heading back to create each row. This is each row. So this is creating each row. We run it twice to create a row of 4 because I just wanted to alternate the colors, and I just chose to do it this way. Every time we're creating a fractal, it's mini first fractals. And here's the other one. So, for mini first fractals, every time it goes through, it sends the order of 2, which we established at the very beginning, actually. Oh, and we do it 4 times. So we're running the recursion 4 times each time. So now we've passed through the order of 2. What happens is order does not equal 0, so it goes to the else. It will go here and remember, it'll read this, and it'll remember that it was called, so it kind of keeps it stored in Python memory that it was called but not completed. It will then -1 from the order, and handle the size. And it will go back to the if-else statement because it's been just called itself, so it can't go forward right now. So then order is 1, which is not 0, so it goes to the else, and then it minuses 1 again, and then it goes back again because it called itself, but it still remembers that it called itself twice. Now the order is 0, so it moves forward, and now it can do this twice. And then it turns right, and then it starts all over again. And it goes back and forth from 0 to the order number, and it does each of these. And it goes through on the top here, and then over here, and then over here, and then over here. And that's how it creates that squarish shape. The very last one was a lot of fun to make. So first thing I do is I set up all these pretty lines, and because I don't want to calculate the length of each line on this triangle, all I do is I just fill the entire square with these lines. And then I make a nice big triangle, beep, 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 right there. And then I created the Sierpinski triangles, which is triangles within triangles within triangles. So what happens first? Again, I'm passing through, I believe the order was 4. Let's find out. Yep, 4. So I have these 3 triangles is 1, these 3 triangles is 2, these 3 triangles is 3, and these 3 triangles is 4. So every time it goes through, again, just like the last one, it goes here and it says, oh, I need to call myself, and then -1 to the order, and it's going to do that 3 times till it gets to, or 4 times till it gets to 0, and then it'll make a triangle. And this is one triangle, but because I decided to call this 3 times, it's going to make 3 triangles every single time. And that's my program.